Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback of the concurrents regarding the quality of audio as well as video. If the quality of audio as well as video is perfectly transmitted from our side, just right, perfect over the live chat, so at least I'll have the fair idea. So just write perfect if the quality of audio as well as video is perfectly transmitted from our side. My dear friend, the agenda behind the basics of the engineering mathematics which we have been running and the 6 videos already got over in previous classes must be known to all of us. We have started the engineering mathematics from the very scratch, from the very basics. If you guys would be able to recall what are the different basics has been taught in last 6 number of videos, at very beginning in first video I was discussing about the logarithmic function. Once we were done with the logarithmic function, in the video number 2, 3, 4, 5, I was discussing about the straight line. 2, 3, 4, I was discussing about the straight line. In video number 5, I was discussing about the trigonometric function. In video number 6, I was discussing about the indeterminate form. Why I am repeating it once again? Because the student who have been new and they have straight away jumped into this video first time, they must have a fair idea what has been the agenda behind the series of the engineering mathematics which we have been running and what are the different topics has been covered in past. So without going to go much detail of the process which we have been following, let me recall what are the different topics which we have covered so far. What are the different topics which we have covered so far? So the student who are new, definitely they can have the reference in basis of the topic name. In first video, the video number 1, I was discussing about the logarithmic function. I talked about the logarithmic function in the great detail. Yes, you must go there and just learn about the logarithmic function, because I have seen many of the students exactly do not know from where the concept of the logarithmic function itself have come into the picture. Once you are done with the video number 1, in video number 2, 3 and 4, I have discussed about the straight line, where I took the reference of straight line drawn over the 2D xy plane. And even we talked about the different kinds of the mathematical equation through which I can address the straight line. Similarly, when you will be finding the no solution case, infinitely many solution case, when both of them or both of the straight line would be parallel to each other, when they would be perpendicular to each other, when the two straight line becomes perpendicular to each other, what used to be their multiplications of the slope. There are several kinds of the different aspects were taken care while discussing about the straight line, and even we discussed around 6 to 7 number of problems based on straight line. Once we were done with the straight line, and the next video, which was video number 5, there I was discussed about trigonometric functions and trigonometric ratios. So I could understand what was the need of sine, cosine, tan, sec, cosec and cot. And similarly, we also drew how it would look like over the 2D plane if we draw the sine of x over the 2D plane, where the vertical axis has been y-axis, horizontal axis has been x-axis. Similarly, how the cot of x would look like, how the tan of x would look like. Obviously, it would be a very important curve, because many of the times you deal with the trigonometric functions and you exactly do not know how it gets drawn over the xy plane. So it is a very important topic to at least understand in terms of curve basis. Once we were done with this, in last video precisely I was discussing about indeterminate case. Video number 6, you can say. Video number 6. In video number 6, I was discussing about indeterminate form. And even I did its complete surgery, from where the 7 different kinds of the indeterminate form have come into the picture, why they have been said to be indeterminate form, and why we have got only 7 precise most indeterminate form. Keep in mind, in future, if you get any of these structure apart from 7 indeterminate form, the result would not be indeterminate, it would be determinate. Maybe it could be infinity, it could be minus infinity, it could be 0, it could be 0 minus, it could be 0 plus, but yes, they would be form of determinate case. Yes. So the agenda behind today's video has been very precise and clear. That has been video number 7, video number of 7. Yes, the today's video. I am not focusing over the comment which are coming over the live chat, keep in mind, because I had to focus over the study such that you would be keep connected. End of the day, when the lecture would get over, definitely I would watch towards the live chat also. So I would request to each one of you, the student who have been following my mathematics lecture, they must also be present with the pen and copy. Whatever I say over here, that should go in your copy. Until and unless the concepts, the agendas, as well as the curve which we are going to discuss over the digital board, it's not going in your copy, definitely you are not going to get benefited. Because the GATE 2022 is going to come approximately after 1 year, and until and unless you do not have a concise form of the note, you would not be able to refer, or you will not be able to refresh before the examination. You are done. That is what I used to say. Whenever you follow my lecture, try to write all of the important point over the copy itself, such that the reference would become more stronger. In today's video, we are going to discuss about circle, and once we are done with the circle, and if the time permits, we would be discussing about the parabolas. And they had been the two important curves specifically in terms of GATE, because here and there you would have the usage of these two important curves, maybe in engineering mathematics, or maybe in your core technical, yes. So let me go into the next page and write it down, the agenda behind today's video, which has been video number 7. And at very beginning, let me discuss about this circle. See, the name itself is quite self-explanatory. We are going to deal with a circular function or circular curve. That means it must start from a certain point, and after getting traveled, it should come to the same point again. That means it has to be a closed path. That's the first thing. And while traveling, it must be performing a circular rotation. Anyways, without going into the much theoretical detail, let me straight away hop into its important properties. To draw the circle over the 2D plane, I have taken the reference of XY plane. It has been my x-axis, it has been my y-axis. And let's take here the circle has been drawn. Yes. I can shift this circle a bit. Yes. For the time being, this circle had the character that it has been centered along the origin, and for the time being it has been taken, the radius of this circle had been r. What I am saying, the center of this circle had been origin. What does it mean by the origin? That has already been communicated in earlier classes. The origin used to be the intersection of y is equals to 0 axis and x is equals to 0 axis. Put together is gonna be 0, 0. And similarly, for the time being, the resistance of this circle has been taken as r. So few of the important points we can write regarding the circle. Circle is a closed path. Maintains the uniform distance from its center called radius. Yes. So by definition itself, it's quite self-explanatory. The circle is gonna be a closed path. That means if you take this as a starting point, all the way it is going to rotate and again coming back to the same point. It is a closed path. Secondly, even you can have any random path as a closed path. Then what's the difference between this random closed path and this circle? Yes, it had a certain specific requirement. What it is? Circle is a closed path, maintains the uniform distance from its center called radius. Obviously, if you take any point over this closed path, you will get to know from its center the distance has always been constant. For the time being, that has been taken as r, and in future that r would be called as the radius. Till this point, nobody should have any doubt as such. But it is not necessary that the circle would always be centered along the origin. Even it can be displaced towards the x-axis, it can be displaced towards the positive y-axis, negative y-axis, negative x-axis, and even you can bring it to the first quadrant, second quadrant, third quadrant, fourth quadrant, even you can mix it to the reference of the first as well as fourth quadrant both. So what I am saying, at very beginning, although I have taken the reference of a circle which has been centered along the origin, but in future you can have the displacement of its center also, maybe in first, second, third or fourth quadrant, or maybe over the x as well as y axis. So just to encounter, just to encapsulate all of the possible conditions, what I did, rather taking its center as 0, 0, I have taken its center as a, b, where the a could be positive, negative, b could be positive, negative, and even they can be 0 partially or completely. So what I am going to do over here, I am going to draw a next circle, and this is going to cover the better dimension. Just a minute. Let's take it has been the center of this circle. It has been the center of the circle. Somewhere here, you yourself would be able to understand. It has been a center of the circle, and the center of the circle has been at the coordinate a, b, where the a is the worth of abscissa and b is the worth of ordinate, and the worth of radius has been small r again. It has been circle number 1. It has been circle number 2. So the next important thing regarding this circle, and that is governing mathematical equation. Which equation must be governed by circle which has been centered along a, b and had the radius is equals to r. Many of us must be knowing about it. Yes, and what it is? That is nothing but x minus of a to the power of 2, y minus of b raised to 2 is equals to of r square, and you can write this has been the governing equation or the governing mathematical equation for circle number 2, where a, b had been center of the circle. The name itself is self-explanatory. It's gonna be the centermost point of the circle, and similarly the r is gonna be radius of the circle. R is gonna be the radius of the circle. In the same sequence, let me move ahead. Again, let me take a xy plane. Here goes the y-axis, here comes the x-axis, here comes a circle, had the center at a, b, and had the radius as r. See, whenever we deal with the circle, we come across few of the important terminologies or important words which used to be asked again and again, specifically in the aptitude part of the mathematics, like the words like radius, diameter, secant, tangent, chord. Those all 4 to 5 number of words are very important because they are not very tough to understand, but until and unless you exactly do not know the word has been used for which particular purpose, you may not be able to actually understand the problem, or you may not be able to decode the problem. Yes, so we are going to discuss about the 4 to 5 important words which comes again and again, or which comes very frequent when we deal with any kind of circle. Could you understand what I am saying? Each and everything is fine now. So here what is happening, at very beginning I am going to discuss about chord. Tell me, what does that mean by the chord? You yourself would be able to understand probably. What is the chord over here? Which has been started, let's take from point A, got terminated at point B. And this has been called CHORD. Can you define, Or can you have the definition of the chord? The chord is a line segment. It's not line. Line would not have any ending. It would keep be moving towards the left hand side. It would keep be moving towards the right hand side. And obviously its length is going to be infinite. But I am not going to discuss about the line. It's going to be the segment of the line. And hence it would have a finite length also. Yes. The chord has been a line segment which joins the 2 point which has been kept over the circle. It could be AB, even it could be BC, even it could be CD. Yes. So here the AB is the chord. AB had been the chord. AB had been the chord. And what's the definition of the chord? It's a line segment. It's the line segment. Line segment connects the 2 points on the circle. And obviously its length is going to be finite, as we have been dealing with the line segment. Finite length. Yes, this would be the first important word within the circle. The second important word is going to be diameter. May I know how will you define the diameter? The diameter is again gonna be a type of chord. If you have kept one point A over here, B over here, let's take, you have taken a situation where the C was kept somewhere here, D was kept somewhere here, and once you're joining a line segment, it has been passing through the origin, it has been passing through the center of the circle. In that case, it remains a chord, but now that specific type of chord is being decided or being divided as the diameter of the circle. Could you understand what I am saying? So what would be the definition of the diameter? Diameter is a longest length of the chord within the circle, or diameter is a chord which passes or crosses through the center of the circle. Could you understand what I am saying? So let me move forward. Let me take another definition. Even it could have been anything. No, I am not saying that both of them are parallel to each other, but one thing is quite sure. If you take the references of their points, let's take this point had been C, D. The CD had been a diameter. Diameter. The diameter had been C of D. Diameter. Again, if we'll talk about its length, finite in length, because it has got ending towards left as well as right hand side. So we can write its definition. It is a chord with the highest length. It is a chord with the highest length and crosses through center of the circle, crosses through the center of the circle. So from here onwards, whenever you have a chord, what does that mean by the chord? That it must be ending towards a 2 point over the circle, and if it crosses through the center of the circle, by default keep in mind it becomes your diameter, and the diameter used to be the highest chord length. You yourself would be able to understand. Let's take the CD had been a chord. If you have drawn another chord above CD, let's take, which has been parallel to CD, may I know, if you'll talk about its chord length, would it be larger than CD or would it be smaller than CD? Obviously it's going to be smaller than CD. That means if you take the reference of a chord which is lower than CD or which is upper than CD, obviously their length or the chord length is going to be lesser than the value of CD itself. Yeah. So that is also another important point. The next important point goes like, how many diameter structure you may have within the circle? Infinite diameter structure you may have the circle, because a chord or the line segment which has been passing through the center of the circle by default would become a diameter. So you can have this as a diameter, you can have this as a diameter, you can have this as a diameter. They all are the diameters of the circle alone. Yes. So we can write infinite ways diameter we can write longest chord length can cross through the center. So the two important wordings which are involved within the circle has clearly been communicated over here. First was chord, the second was diameter. Once we are done with this, now the next wording which we are going to discuss about, it's gonna be secant. It's gonna be a secant. Let's see how it would look like. It is secant. You yourself would be able to understand what's the difference between diameter and chord and what's the difference between the secant. Secant has been a line, it's not a line segment. I can say it's a line which has been crossing through the 2 points over the circle. And one thing must be clear to all of us. The secant would have precisely 2 intersection point over the circle. Either you take this, either you take this, neither it can't be precisely 1, nor it can be 3 or 4 or 5. Any of these straight line, if you are drawing, always through the circle there would be 2 intersection point. If it is entering to the circle to this point, obviously it has to leave out from some other point. Yes, so secant is gonna be a straight line. It's not a line segment. It has been a secant is a straight line. Secant is a straight line, crosses through the precise 2 points, crosses through the 2 points of this circle. Similarly, let me focus over the another type of line which would just be touching the circle, kissing the circle, and would move forward towards left as well as right hand side or top or the bottom side. Let me take the reference of that also. I have taken sort of this. It has been a line, so obviously it would not have any end towards either left hand side or the right hand side. So this has been what? Secant. And this has been tangent. I don't know the definition of the tangent, and yes, the problem has come from this domain again and again. Specifically this year in electrical, one problem do come from the concept of the tangent when it was drawn over the circle, and probably 3 years back also in mechanical the same problem has been fabricated where the tangent has to be fabricated over the circle. Tangent. Anyways, what is a tangent? Tangent is a straight line. That means still it would be following the same equations which were followed by the straight line. The tangent is a straight line which just kisses or touches the circle and passes away. It would not have any intersection. That's the difference between secant, and that's the difference between tangent. Secant would have an intersection, and similarly tangent would have only and only kissing point. Yes, so you can write tangent is a straight line which just kisses the circle at certain point. Why I am writing it certain point? Because that point could be here, that point could be here. Certain point. If you want to take the reference of the example, this line number 2 would be the example of, this line number 2 would be the example of tangent, and similarly line number 1 would be the example of secant. Now few more important properties within the tangent. At any point over the circle you would have only and only unique one tangent, because if you draw any of the other straight line apart from the tangent over that point, what would happen? There would be a little bit difference or little bit variation in their slope, and once the slope gets changed, keep in mind, rather kissing over that point, it would have the intersection. Now either you do like this, either you do like this, either you do like this, either you do like this. Agreed? So one of the important point, tangent at any point over circle is unique. Over circle is unique. Could you understand what I am saying? Circle is unique. That's the first important point within the tangent itself. How many number of tangents can be drawn? How many tangents can be drawn over the circle? Infinite number of tangents if the points of observation is supposed to change. Like you can have this, you can have this, you can have this. How many number of ways you are able to draw the tangent? Yes, it has been tangent. No, it has been tangent. So infinite number of ways the tangent can be drawn over the different points over the circle. And how many number of points are there over the circle? Infinite number of points, and hence the infinite number of tangent. But keep in mind, at a fixed or the precise point over the circle, only one straight line would be the tangent. Apart from that straight line, the remaining straight lines are going to be secant. If the straight line you have taken, which has been passing through this point, and if the slope has been changed apart from a tangent, by default it would have the intersection over the circle now. Agreed now? So till this point, each and everything must be clear to all of us. Yes, so better to write over here. At different point on the circle, tangents are different. How many ways you can write it? Infinite. The infinite number of ways you can have this structure. Anyways, in the same sequence, let me move forward. I have taken the reference of a xy plane. Let me draw the circle over here. Few more important points. See, what are they? Just a minute. Let's take here, you had the center somewhere. Where? Somewhere here. Yes, no? It would be your center point. You had a point outside from the circle. Let's take that point had been somewhere here. And from this point you are going to draw the tangent over the circle. How many tangent you can draw? Obviously exactly 2 number of tangent you can draw. How? You yourself would be able to understand it. It has been started from here. Just a minute. It has been started from here, and it is just kissing to this point and it's moving forward. And similarly, if you try to draw the another tangent, you can draw towards downside. It is just kissing this point and going ahead. So if you want to write, you can write somewhere. From outside the circle, if a point is taken, outside from the circle, if a point is taken, outside from the circle, if a point is taken, exactly 2 number of tangent can be drawn over the circle. That's the first thing. That's the first thing. Next. It has been a point of touch. It has been a point of touch. Yes. And if from the point of touch, I have taken a line segment which has get connected towards the center of the circle, and similarly I have taken another line segment which have got connected to the center of the circle. One of the important outcome do come into the picture, and that has been they used to be perpendicular to each other. That means the tangent what you had and the line segment which has been connected from the point of kissing to the center used to be 90 degree apart from each other. From where this concept have come, you need not to understand, at least for the sake of preparation of the engineering mathematics for the gate, that comes from the concept of congruency. And even if you connect them together, you will get to know their angle used to be same. If this angle has been alpha, this would also be alpha. If this length has been, let's take it has been AB, by default the length would be again same as AC, and it has been O. So from here at least one thing must be clear to all of us. The angle has been taken as alpha, beta. Alpha and beta would always be same while doing this structure, while making this structure. Could you understand whether it is understandable to all of us? Yes, it must be. This angle and this angle has to be very same, where the first angle has been made in between. The A was extended till O and A has been extended till B, where the B was a point of kissing, a point of tangent over the circle B, and similarly here goes OAC. Or I can say OAB is very same as OAC. The value of alpha and beta would be very same. This is all you have to remember. And here you get ABO is equals to of ACO, and that has been equals to of 90 degree. So in future you can expect the problem may get asked. What I am saying, in future you may expect the problem may get asked based on the concept of a right angle triangle, because already it had become a right angle triangle. So the arm in front of right angle triangle would become hypotenuse in future. So whenever the calculation would be done, OA would be treated as a hypotenuse, and the remaining two sides, if I take a reference of ABO, the remaining two sides, this as well as radius, would be taken as perpendicular in base. And similarly, if I take the reference of the lower sided triangle, there I would be taking the reference of obviously this as base and maybe this as perpendicular. Till this point, each and everything must be clear to all of us. Let me show what I wanted to say. As far as the circle is concerned, it is a closed path, but it always maintains the distance from your center uniform. For the time being, that uniform distance has been R, which has been called as a radius in future. The governing mathematical equation which would get formed or which would get followed throughout the range of x and y, it has been x minus of a to the power of 2, y minus b raised to 2 is equals to of r square, where the a comma b had been the center of the circle and r had been the radius of the given circle, which we have drawn over here. Here deliberately I have taken the center of the circle towards the origin side, but in general it can be at any side, maybe first, second, third or fourth quadrant. In the same sequence, we were talking about few of the important terminologies which get involved while doing the analysis with the circle. The first important point was the chord. The chord is nothing but a line segment which joins the 2 points over the circle. It could have been like AB, it could have been like AC, it could have been like AD. In the same sequence, we are going forward a bit, and that's nothing but the chord. Diameter. That diameter is a specific character or a specific type of chord when it crosses through the center of the circle. Like the CD again has been a type of chord because it has been joining between the 2 points over the circle, but it is also crossing through the center of the circle, and hence it becomes what? Diameter. And in future you had to have one thing in your mind: the diameter is the largest chord present inside this circle. Next goes secant. The secant is a straight line which crosses through the circle precisely 2 number of points. Obviously, you can't have more than 2 number of intersection with the circle if you have been dealing with the straight line. That's a different story together. If you have a sinusoidal signal, you may have 3 or 4 or 5 number of intersection, but the intersection of the circle with the straight line precisely would have the 2 points of the intersection, and for the time being it could be like F and G. It has been a secant. secant. In the same ratio and in the same sequence, we were discussing about the tangent. Tangent, the fundamental of the tangent have come from the concept of kissing. Rather intersecting at a certain point, it's just going to kiss. What does that mean by kiss? At the point of kissing, the slope over the curve and the slope of the straight line would be very same. And when they are very same, definitely they are just going to touch, they are not going to intersect. That is why what we do whenever we discuss about the tangent over any sort of structure, for the time being it has been circle. So what I do, I use to calculate the slope of the circle at this point, and whatever the slope of circle you have at this point, I use to take same as the slope of the straight line which we will be calculating in future, Anyways, that has been tangent. The tangent has been a straight line which just kisses the point over the circle and goes out. You will not have any point of intersection. Now the next thing comes in a picture. At any fixed point, how many number of tangent you can draw? Only one, because if you change the slope of the tangent, what would happen? It would start getting intersected. And similarly, if you change the value of c, y is equals to mx plus c, this point either would get shifted towards downside or upside. Again the same problem would come. Either it would be intersecting 2 points over the circle, or either it may not be even kissing, the circle itself. Till this point, probably each and everything must be clear to all of us. The tangent at any point over circle is unique. The differential point on the circle tangent are different infinity. How many number of points you have over the circle? Definitely the infinite number of points you have over the circle. So if you're really interested to find all possible tangents over the circle at the different points, each and individual points will have the different tangents. How many points you have? The infinite number of points you have. So how many number of tangent you can draw? The infinite number of different tangents you can draw. Now here goes the next step. This has been the circle, and deliberately what I did, I took a point A which has been outside from the circle. Yes, it has been point A, and from point A I tried to draw the tangent over the circle. First things would come in our mind, sir, how many number of tangent you can draw? Only 2 number of tangent you can draw towards the upside and towards downside. If that point would have been towards upside, you would have only 2 tangent towards right hand side, towards left hand side. So you can write somewhere from the outside only 2 number of tangent can be drawn over the circle. That's the first story together. Now the point of kissing is getting connected to the center of the circle. Point of this kissing has been connected to the center of the circle. You yourself would be able to understand the angle which was subtended is precisely 90 degree. Not only that, from the concept of the congruency, we got to know this has been radius. They have to be very same. Even AB is very same as AC, and similarly AO has been common. You can expect this sort of problem may get asked into the future examination. Now let me focus a bit more about the circle. Probably in today's lecture we may not be able to enter into the parabolas, so I would be confining myself till the studies of the circle itself, so you need not to have any impatient at least. Let me discuss few more important or more critical points regarding this circle now. Let's take you had a circle which has been centered around the origin. In future, many of the times you come across a situation where the line integration has to be performed across a certain closed path or the open path. Let's take for the time being that path had been circular in nature. What we do there, I used to use the method of parametrization. What does it mean by the parametrization? That means the 2 independent variables, the x and y, 2 number of variables what we had, the x and y, would try to be dependent over a single variable. How it is happening? You yourself would be able to understand what is happening over here. The x square plus of y square is equals to r square would get followed everywhere over this point of circle. So in future, keeping x or understanding x isolatedly different, understanding y isolatedly different, why don't we depend x and y towards the next variable? For the time being, that variable is said to be parametric variable, and the parametric variable has been taken as t. It has been x-axis, it has been y-axis, and the parametric variable or parametric conversion of circular path used to be x is equals to of r of cos t, y is equals to of r of sin t, and the mathematical equation which is getting satisfied by the above circular pattern had been x square plus of y square is equals to of r square, and that is what is happening over here. If you keep x as r cos t, if you keep y is equals to r sin t, obviously if you take the square it would become r square, which it had been taken as common. In between towards the bracket side you will be having only sin square t plus of cos square t. End of the day you are getting the same result towards left hand side as well as right hand side. R square is equals to of r square. So obviously it seems to be a valid parametric form. But still many of the students used to have one doubt, sir, rather writing it x is equals to of r cos t, why don't we write r sin t, and rather writing y is equals to r sin t, can't we write r cos t? No, because in that case also this equation is getting satisfied, but the complete methodology is not getting matched. See. The t had been the angle, and obviously the t had been parametric variable. The t had been in angles and had been the parametric variables. See what I would try to do, understand over here. At very beginning, let me take the t had been 0. I can write either in degrees or either in radians. So what becomes x over here? The x becomes r and y becomes 0. Yes, and you yourself would be able to understand. Let's take this horizontal line has been taken as 0 degree. This horizontal line has been taken as plus 90 degree, had been taken as minus plus 180 degree, and had been taken as plus 270 degree. Obviously, t is keep changing its angle. The t had been keep changing its angle. Here it had been 0, here it had been 45, 90, similarly 180. Anyways, let me remove this juggleries. When the t was 0, you yourself would be able to understand where your point has been lying. That point has been lying over the positive x-axis with the radial distance of r. Definitely the value of coordinate has to be r comma 0, and it has been. At t is equals to 0 precisely, you have been reaching to the point r comma 0, where the value of abscissa has been 0 and the value of ordinate has been 0. Similarly, if you will move ahead with taking the value of t is equals to 90 degree, if you will take the t is equals to of 90 degree, what is happening over here? The x becomes 0 now, the y becomes r now. Yes, nobody would deny on it. The r of cos 90, the cos 90 would become 0, 0 getting multiplied with the 0, the value of ordinate would become 0, and similarly the value of yes. So here obviously you have reached to the point 0 comma of r, and if you will start feeding the values, you will get to know everywhere it is going to match now. Everywhere you are going to match now. That means what I am saying, rather writing this as the equation of circle, rather writing this as equation of circle, can't I write r of cos t comma of r of sin t? Obviously it is a point, or it is a point over a coordinate where the t is moving from 0 to 2 pi. Yes, can't I write this as a first form of representing the mathematical equation of the circle, and this as the second form of the representation of the circle in terms of the point itself? Let's take, if you will keep the t is equals to what 0, it would become r, it would become 0, and as you will keep the higher value of 2, let's take it 0 plus, the next point would come over here, 0 plus plus, it would come somewhere here. At 45 it would come over 40, 50, and yes, it would always be over the same point. Why? Irrespective of the value of t, once you will take the square both of the side, the result what we are getting is simply going to be x square plus of y square is equals to r square. That means whatever the value of t you may have, but the point has always been following over this circle. That's the first thing. And as the value of t is increasing, could you understand or not? I do not exactly understand. From 0 to pi, what is happening? The perpendicular is keep increasing, whereas base is keep decreasing. Perpendicular is keep increasing, base is keep decreasing. and that is what is supposed to happen. If you'll move over this point, what is happening? The value of x is keep decreasing, the value of y is keep increasing. Here the value of x has been maximum, y had been 0. Here the value of y had been maximum, x has been 0. And yes, it has been matching. No, it has been matching. So what I am saying, if you take the t is equals to 0, by default you have been standing over here, and as the value of t is keep increasing, you have been moving in the ACW, anti-clockwise direction. Anti-clockwise direction. So if I say you had a parametric form of a curve r cos t comma of r sin t, and you have started taking t is equals to 0, and slowly you moved till t is equals to 2 pi. What would be the circular, what would be the path? The path is going to be a perfect circle having radius is equals to r, centered along the origin, I would like to give a homework to all of us. Just tell me what would be the parametric form of the circle if it has been centered along a comma b, that you had to do in your home. Now if you had to change the direction of this circular rotation to the ACW to the CW, what's the change you had to expect? Obviously the theta has to get replaced with the minus of t. So here it becomes minus of t, here it becomes minus of t. The cos of minus of t, it would remain cos of t, and similarly sin of minus of t would become minus of r sin t, minus of r sin t. Agreed, no? Agreed. So I would expect in future, whenever I would be discussing about the line integration, maybe the vector line integration or the scalar line integration, each one of us must be agreeing and must be appreciating the concept of the parametric form of the circle. Once we are done with this, let me move forward. Here goes the circle. The two important parameters we use to discuss about it. May I know what are they? The area of the circle, area of the circle, that used to be pi into of r square. I would suggest to each one of you, specifically in GATE, nobody should write pi as 22 divided by 7, because the pi has been irrational number and you're just fitting pi as a 22 divided by 7. That means you are just approximating a irrational number to a rational number. Definitely you would lead certain error while taking pi as a 22 divided by 7. So I would suggest to each one of you, use the pi button which we used to have in our soft calculator during the examination. Nobody should use the 22 divided by 7. But yes, this has been the area. Occupied by the circle. It would be unit square. Once we are done with this, we can move forward. Yes, what it is? Here we talk about the circumference. Circumference, that means if you start from a certain point and if you take a complete one rotation, how much length you have traveled. How much length? I am not saying how much displacement. If we talk about the displacement would become 0. How much length you have traveled? The value used to be 2 pi r. And this has been the complete circle. Sometimes we also refer the word called semicircle. How the semicircle would look like? The name itself is quite self-explanatory. The half of the circle is said to be semicircle. That means even its area would become half. And as well as its circumference would also get half. Most of the time people do not consider this as a part of circumference. The circumference would also get half. What it is? It's a semicircle. Yes, once we are done with this, we would move forward. And that's nothing but the quarter circle. We can take even the reference of quarter circle also. How the quarter circle would look like? You have to take the 1/4 part of it. This became half of it, and this became quarter of it. Yes. And it's called quarter circle. So obviously its area would also be quarter. Area would also be quarter. So this is all about the basic understanding of the circle, and even the problems related to the tangent which were drawn over the circle, we have already been discussed over the concept of the straight line. So each one of us should also study each and everything in coherency, in continuity. End of the day you will be getting each and everything very perfect. Anyways, tomorrow had been the great day of Holi, so I would say just enjoy without having any tension regarding your study and all, because sometime refreshing your mind is equally important. If you are always in pain, if you are always in thought process, what happens? Your mind start getting hanged. So I would request to each one of you, leave aside each and everything and just focus over your enjoyment. And once you are getting refreshed again, maybe from day after tomorrow and after 2 days, you can come back to your study and you can put your complete effort. So from my side, from the complete Gate Academy side, wish you happy Deepavali, and we would meet with the next schedule, which would be probably after 2 days. Okay then, this is all about the circle. This is all about the lecture number 7. Bye bye. Take care. Good night.